Hello, today we will have a look at one table and we will learn how to use some basic SQL statements to make queries against this table. And the purpose is to retrieve the wanted data from the database. The statements we will use belong to the DML part of the SQL, and DML stands for Data Manipulation Language. We have earlier looked at the insert statement, the update statement and the delete statement, but today we will look at how to use the select statement, which is the one that is used when we want to retrieve data from the database. As an example, we will use a table named car, and that was a table that we imported from Excel in an earlier video. And here we see the basic syntax for a select query. First we have select, and then we specify the column or columns to be showed or retrieved. In our table we have 6 columns, so maybe we only want to show this first one and the color column for instance. Then we can specify these 2 columns in the select part. Then in the from part we specify which table or tables we will retrieve the data from, and in our example we only have one table, and that is the car table. Join is something we use if we want to join several tables, but for this example we only have one table, the car table, so we will look at that in a later video. And we have the where part, where we can specify the row conditions, and that means which rows we want to retrieve. We can filter the rows so that we don't have to return all the rows in the table. Maybe, for instance, want to return only the rows with the red cars. And then we can specify that as a criteria in the where part. It is also possible to group the result. If we, for instance, want to consider all the Peugeots as one group and all the Volvos as another group and so on, then we use the group by statement. And then we can also do calculations related to the groups. So we can find the average price for each group, for instance, like the average price for these 3 Peugeots, and similar for the other groups. So after having grouped, we can use an aggregate function like average, and then we put the aggregate function in the select part. But it will do its calculations on the group specified down here. And like we could use where to filter the rows, we can use having to filter the groups. If we, for instance, have grouped on the car make and calculated the average price for each group, then we could use the having statement if we only want to see the groups where the average price, for instance, is more than 500,000. So we can specify that kind of criteria that will work as a criteria for the group selection. And when we have some kind of results, some rows as a result from this select part, then we can order if we want to. And then we specify the column or columns we want to order on, and we specify if we want to order it ascending or descending. In that way we can sort the result. And this is the basic select structure, and we will now look at some examples. The most basic select query is if we want to select all the columns, then we can use this star, and all the rows, then we don't use any where filtering. I go to SQL Server and the car database and open a new query window. Then we can run this query. Execute, and we see down here that we have all the rows in the table listed. The table has 6 columns and 9 rows. Let's say that we only want to list these 3 columns, reg number, car make and price, but all the rows. Then we can run this query, execute, and we see now that we have filtered so that we only see the 3 columns, and then we can say that we have projected the table on these 3 columns. But we didn't specify any where conditions, so we will have listed all the rows in the table, all the 9 rows. If I want to list all the car makes, then I can use the select car make, specify this column, and I say the table I want to list them from, which is car. So I run this query, and now I see I will get only this column. But we see that since it's several rows that registered with Peugeots, then we will have 3 instances of this one. Maybe we would have several Toyotas and several Volvos, etc. And if we then wanted to make a list with only one instance of each car make, just to see how many different car makes we had, then we could use the distinct keyword. So if I put this in here, I can run both the old one and the new one, select both and click execute. Then we can see when I use the distinct word, then this Peugeot only shows up once. So when we use distinct, only the first instance of the specified distinct field will be retrieved and shown, so that both this one and the last one here will be filtered. Earlier I said that we could use a where clause to filter which rows we want in return from the query. Here I have a simple query which will return values from 3 columns from the table named car. And if I don't use any where clause, then it will return all the rows in the table. But now I only want the rows where there are registered blue cars. And we register the car color in the column named color. And then I, with this equal sign, will check if the color is blue for each row. And only these rows will be included in the result set. So if I run this query, both without this where clause and with this where clause, we can see the result. And here we see from the first one that all rows are returned, and in the second one only the rows where the color blue is registered in the color column have been returned. So we checked all the rows for values exactly like the value we specified here. But it's not always that we want to check if a value is exactly like a value. Sometimes we want to use a wildcard instead to specify that whatever the characters are here, as long as it starts with what we put in front here, we want the rows in return. And then we use the like keyword instead. So when we write reg number, where reg number like y and this % sign, then all the reg numbers that starts with a y will be returned. And I could also use more letters than y here. Everything that's in front here will have to be an absolute criteria, but whatever the last part of the word is, it will be accepted. We see that we have 2 reg numbers that starts with a y. I will now run this query that will return only those values. But I will at the same time run the query that returns all the values so that we can easily compare it. I run it too. I see this is all the rows, and here I will have only the rows that have a reg number that starts with a y. And if I change it to yc, then I will have only this one in return, like this. And if I instead wanted to return all the reg numbers that has a number that ends with 9, then I could put the % sign first and the number 9 after. So now I run it again, and I see that now I will only have these 2 rows in return. The where condition can also be used with relational operators like smaller than, greater than, equal than, greater or equal, and so on, and logical operators like and or and not. I advise you to use parentheses to avoid any misunderstanding. If you, for instance, didn't have used parentheses here, then it could be a question if it was this one or this one, and then ANDed with this one, or if it was this one, or both this one and this one. So be precise so that you're sure of what you will have in return. I will now run this one to list all my columns and all my rows, and I will run this other query where I only have to want to list the cars where the price is less than 300,000 or the price is greater than 450,000, and I will only include the cars that are blue, have the color blue. So then it's not enough to fulfill only this one, you also have to fulfill this one. And we run it. Here we see all the results, all the rows, and here we have filtered the data. So we see that 250,000 is less than 300,000 and 460,000 are greater than 450,000, and both have the color blue. So if this had been a red one, then it would not have been part of the result. There's also a between statement. So if you want to check if the price is in the interval from 250,000 to 460,000, then we can write where price between the first value and the second value. But be aware that it also includes the limits. We could instead have written where price is greater than or equal to 250,000 and price less or equal than 460,000. Sometimes we want the data in the result set to be listed in a certain order. Then we can use the order by statement. We can then specify a column or several columns to order by, and we can specify if we want it ordered ascending or descending. If I run this query without any order instruction, then I will list all my rows, and I see that it will normally be ordered on the first column here, which is the reg number. So we see that C comes before D and F and K and so on. But if I rather want it ordered on this car make column, then I can add order by car make ascending to my query, and then I will order by this column and it will be ordered ascending. I can run the queries both with ordering and without ordering, and we can see the difference. So I see that in the second one it's now ordered by car make, so that I have Audi first and then Honda and so on. If I change this to descending and run it again, execute, then I will see that Audi is at the bottom and Volvo is at the top. We can also have ordering on more than one column. Now we are ordering by car make, so we see that we have 3 Peugeots, but this color is not ordered within the group. But if I add a comma and color and ascending, then I will have blue, blue, green instead. So we can execute this one, and we see that now it's first ordered on the car make, and then within each car make it's ordered on color. We have seen that in the select part we specify the columns we want the data in return from, and we can in the same part also specify a calculated column. So if I, for instance, not only want the price, but I want also a column with the price multiplied with 1.25, then I just use a comma to separate from the last column, and I write price and the formula, and to give it a proper column name I use as and specify a column name. If the column name consists of several words, then we need to use these brackets. In SQL Server we don't have to use this as keyword, but I advise you to do it, because if you are going to transfer this code to another system, then maybe it's obligatory, because this is a part of the standard SQL. Now I can run the query, included the column name for the new column, and then I can go to this upper part again and say that column name is going to be that included. If I run it once more now, then I will see my new column name. So this isn't the real column in the table, it's just a calculated column that we want to show in our result. There are lots of functions that can be used in SQL Server, and we will have a look at some aggregate functions and some format functions. So we have this aggregation function for calculating the average, the sum, count how many rows there are in the table, and find the minimum value and the maximum value. The calculation will be done in the select part, so we can specify the name of the column and say that we want to calculate, for instance, the average of the values in this column. Then SQL Server will go through each row in the column and calculate the average. So if we try this on the car table, execute, and I see that the result was 383,333 and point some decimals. If I don't want all these decimals, I can also round the result. And in SQL Server we have a round function. It's constructed with two parameters, so we have to send the two arguments, and the first argument is the function that we calculated the average with, and the second argument is how many decimals we want it to be rounded to. So if I run both the queries, I will see the first one from the previous query, and now I see that the second one has rounded to only 2 decimals. Since these are calculated columns, we will see that they have no column name, but I can use this as keyword and tell a column name, and if it consists of only one word, as I said earlier, we don't have to use those brackets. So if I run them now, execute, I see that now I have a column name, and it will be price, which I specified here. There are also several format options available, and we can use this format function, and then we send in the value as an argument, and we can specify a C for currency, and we can specify NO for Norwegian currency. And you have of course other options, but then you have to check the manual. I will run all these 3 queries, and now I see without rounding I had 4 decimals, with rounding I have 2 decimals, and in the last query I have it formatted as a currency format. And we can use the same function if we want to format a date format, for instance. I run this also, execute, and then I see that the date is formatted as specified here. We can also use a group by statement to group the result, group the rows after we have filtered them. And if we like here, group on car make, that means that all the Volvos will be considered as a group, all the Hondas will be considered as another group, and so on. And then we can let the SQL Server do calculations on the group. So here I have specified some calculations, and we do that in the select part. We will calculate the minimum price. That means the lowest price on any of the Volvos, on any of the Hondas, and so on, and the average price for all the cars within each group, and the maximum price, and we will also count the number of cars that are included in each group. If we run this query, click execute, and then we will see that in most of the groups we have only one car. It's only one Audi, one Honda, and one Mazda, and so on, but we have 3 Peugeots. So in this example, this is the only group that it's meaningful to find the minimum, maximum, and average price for. Here we can see the results calculated. So now we don't calculate the prices of all the cars. We just calculate the prices for all the cars within each group. In the same manner as we were filtering the rows with the where sentence or where clause, we can also filter the groups by using the having statement or having clause. Using the having clause is only meaningful when we have used a group by. But when we use a group by, we can in addition use a where clause to specify which rows that shall be in the result set before we do the group by. And as an example of group by, we can see that we calculated the number of cars within each group in the select part, where we used the count star to count the number of rows. And it was only the Peugeots that had more than one row with data. But if we want to make a query that only returns the groups that include more than one row, then we can specify this in a having clause, like having count star greater than 1. Then it will only return this one because all the other ones had only one car in the group. If I go here now, I saw that my last query returned all the groups, but if I add this having count star greater than 1, then we see that it is only this Peugeot that fulfill this criteria, so it's only that group that should be returned. So execute, and I see that this group was returned correctly. If I change this to, for instance, less than 2, and run it again, then I will see that it will return all the groups except the Peugeot group that had 3 instances. Then we have shown the basics for querying one table, and in a later video we will learn how to join tables when we need to retrieve data from several tables.